All right, first question. This is the Unit 9 Exponential and Logarithmic Functions review. It says draw a circle around each equation or graph that represents an exponential function, or a box around each equation or graph that represents a logarithmic function. So box is actually going to be logarithmic. And then it says put a circle around exponential. There will be more than one correct answer. All right, so let's start with the exponential. We said circle around the exponential. So I'm going to look at each of these. All right, and I know that exponential is going to have an x in the exponent. That's how we remember that. So an x in the exponent is what I'm looking for all of the equations. X in the exponent. Nope. Okay. And graphically, remember that exponential functions have horizontal asymptotes and logarithmic functions have vertical asymptotes. You need to remember this. So a couple ways alphabetically, A, B, C, D, E, F, G, H. So they're closer together in the alphabet, and then you go down to L, V. Or this looks like love to me, so I remember that the L and the V go together. Okay, so exponential have horizontal asymptote. Remember, a horizontal asymptote is going to look like this. And then a vertical asymptote is going to look like this. All right, so horizontal asymptote. Let's see if we have any horizontal asymptotes. I'm going to go ahead and sketch in my asymptotes. So I've got a horizontal asymptote there. That doesn't have an asymptote. I've got a horizontal asymptote here. So I'm going to circle this guy. I'm going to circle this guy. I think that's it. And then let's do a box around logarithmic. Okay, so we know with our equation that we're looking for log. But also remember that the ln means natural log. And remember that logarithmic has vertical asymptotes. So vertical, remember, going to look like this. So there's a vertical asymptote right there. And that is it. Now, once I've done all of that, I'm going to check back to make sure. No, that's radical, polynomial, radical, radical, rational, radical. So I know that I've got all of them. All right, next one. Evaluate each of the following. So if we're going to evaluate, we're going to need our calculator to evaluate. So let's take a look. The first one's log of 256. So to evaluate, you're just going to come to your main screen and notice that here there's a log button. This assumes base 10. So log of 256. And that's going to give me 2.41. And go ahead and round to the nearest tenth. Okay. Next one says the natural log of e to the power of 9. So notice here I have natural log right here, ln. And then the e is above that in blue, so we're going to do second for the e. And then it says to the power of 9. I'm going to arrow out to close the parentheses. So that's going to give me 9. All right, let's go to the other side. I have the log base 4 of 1 over 256. Now, remember I said that this log button right here assumes log base 10. So in order to change that base, this right here is the base, I'm going to go to alpha window number 5. Alpha window number 5, and notice that my cursor now is here so I can put whatever base I want in there. So I'm going to put the 4 as the base, arrow over, and then this is a fraction. So alpha y equals will give you the up and down fraction. 1 over 256. I'm going to arrow out, press enter. So that's going to give me -4. Again, let's look at another one. Log base 27 of 102. Remember to be able to change your base, you're going to do alpha window number 5. And then I can put my base in, 27, 206. Arrow out, press enter, so 1.40. Okay, so if this is evaluate, all you do is plug it into the calculator. All right, next, list the transformations. Okay, so transformation, remember we have our change here. This is going to be left or right if this is exponential. So left or right, remember insiders lie. And then here is going to be up or down. So if we look at this, it says list the transformation of the function below. So I have 5 is going to be my base to the power of x minus 2. So minus 2, insiders lie, says to the right 2. And then the plus 3 is up 3. And then the equation for the parent function in number 3 is going to be f of x equals 5 to the power of x. So that's my parent function. Okay. Number 9. Given that the parent function is f of x equals log base 5 of x, write the equation of the transformed function g of x if it has been shifted up 213 units, shifted left 41 units, and reflected over the x-axis. Okay, so just similarly to the exponential function, remember that we're going to have f of x equals log of x, okay, is my parent function. My 5 is my base, but then we're going to have x. Any changes to my x are going to be plus or minus h. So that's going to be left or right. And then you're going to see a parenthesis around that plus or minus k. It's going to be up or down. And then, of course, in the front, if we have a negative, that's my reflection. So just like any other transformation, these are going to work the same. They just look a little differently. All right, so let's go ahead and do this. So we have f of x equals log base 5. So the first thing it tells me, it's been shifted up 213. So I know that that's a change in k. All right, and then it's been shifted left 41. So I have x, and I'm shifting left 41. Well, left is negative, but we know insiders lie, so plus 41. And then I have my up 213. So the difference between the h and the k is that the h needs to be in the parentheses, okay, because insiders lie. But then we also have this reflection over the x-axis, and we know if we stick a negative in front, that's going to give me my reflection over the x-axis. Okay, so the next says find the equation of the asymptote and the domain for each of the functions. I'm actually going to expand this. Let's say the domain and the range. Okay, all right, so the first one, so we have the natural log of x. So let's go ahead and take a look at that. We're going to go into y equals, and we're going to do the natural log, which is right here, of x. Close my parentheses. Take a look at the graph. Okay, so because this is a logarithmic function, we know we have a vertical asymptote. So I know my vertical asymptote is x equals 0. Okay, so let's go ahead and do the range. If we do left to right, we know here there's no value, so we're going to start at 0. So my domain is going to be 0 to infinity, and my range is going to be negative infinity to positive infinity. So remember, range is down here. And even though you can't tell on the calculator, this is going to keep going down to infinity and get closer and closer to the y-axis. And remember, the y-axis has an equation of x equals 0. Okay, so let's go ahead and go to the next one. Okay, so let's look at the next one. 5 plus log. Notice that this is log base 4. Okay, so I cannot use this log button. I need to do alpha window number 5. My base is 4. And then I have x minus 1. If you notice here that my transformation is going to be right 1 and then up 5. And then we're going to go ahead and go to the graph. Okay, I have an asymptote at x equals 1. And remember, anything that remember our EHLV, anything with a log should have a vertical asymptote, and that starts with x equals. Anything that's exponential should have a horizontal asymptote, and that is y equals. Okay, and then my domain, so it's going to be 1 to infinity, and the range is going to be negative infinity to positive infinity. Okay. All right, let's look at the next one. Go into y equals again. So we have alpha y equals 1/3 to the power of x. Now you want to be careful because notice that this has parentheses around it, so you need to put parentheses around it because the whole thing. Then I'm going to do to the power of x. Arrow out. Sorry, that should be to the power of x. I don't know where that came from. All right, arrow out plus 4. Go ahead and graph that. Now we know already this is exponential. Okay, so we know that it should have a vertical asymptote. So that is a vertical asymptote at y equals 4. Notice that this corresponds, if it's a horizontal asymptote, then it's going to match this. If it's a vertical asymptote, it should be matching this. All right, so then we have a domain of negative infinity to positive infinity. Another way you might see domain written, if it's negative infinity to positive infinity, is all real numbers. We haven't talked about that in a while. You could see it written like that. And then the range, okay, you might see written like this. So we've got our curly bracket, and we have y such that, and we see that we're not starting until 4, and then we're going to positive infinity for the range. Y is greater than 4, and then close your curly brackets. So just remember that we have a different type of notation you might see on multiple choice questions, which looks like this. Okay, but this is also the same as saying that the range is 4 to positive infinity. All right, let's keep going. So let's put this one into y equals. And you could do this without putting into the calculator, but I'll go ahead and do that. Remember the e function is second ln, and then I have x minus 5. And the arrow out. Go ahead and look at the graph. And because there's no shift here for the k, I see that from the graph that my horizontal asymptote, because I have an exponential function, my horizontal asymptote is at y equals 0, which means my domain is negative infinity to positive infinity. And my range is going to be 0 to positive infinity. All right, let's look at some more that don't have the equations. They're just giving us the picture. So my suggestion is to go ahead and draw on your asymptote here. Right, so I have an asymptote right here. Okay, so because I have a vertical asymptote, I know this is logarithmic. So my vertical asymptote is at 1, 2, 3, x equals 3. So then my domain, and I'm going to write this in set notation, my domain is going to be curly bracket x such that x is greater than 3. And then my range down to up is going to be all real numbers. So just to kind of remind you that you could see this several different ways, the notation. All right, let's look at the next one. So I see that I have a horizontal asymptote. So I know my horizontal asymptote is exponential, and that's at -1. So y equals -1. And then I'm going to have my domain. So my domain is negative infinity to positive infinity. And then my range is going to be -1, positive infinity. All right, next one. See that I have a horizontal asymptote. Okay, and my horizontal asymptote, I know horizontal goes with exponential. So I have y equals 0, which means that my domain is negative infinity to positive infinity. And my range is going to be 0 to positive infinity. All right, last one. I see that I have a vertical asymptote at x equals -5. So my domain, we'll write this in set builder notation again, is going to be curly bracket x such that x is, oops, that's on the next, x is greater than 5. And then my range is going to be all real numbers. Okay. All right, next section. You need a calculator for this, so hopefully you have time in class to do this, because you will need to be able to do this on the test. All right, my first suggestion is when you get to a graph where you're going to need to do curve of best fit, is to clear the calculator before and after. So remember to clear the calculator second plus 712. Everything's all cleared. So the first step is to go into Stat, Edit, and I'm going to enter, this is going to be my X value, or list 1, and this is going to be my Y value, which is list 2. Okay, so go ahead and pause the video and enter in your information into L1 and L2. All right, so the question says the table below represents the growth rate of 12 weeping Hejon cherry trees planted in Washington, D.C. This is very relevant because it's almost cherry blossom. And then it gives us the age of the tree in years and the height in feet. Determine whether this is linear regression, logarithmic regression, or exponential. So the first thing you need to do is you've got to go into Stat, Edit, and enter all your information into list 1, list 2. Always scan through, make sure everything looks correct because it could give you wrong information if you're not checking, and look at the bottom of the list to make sure you've got an X value and a Y value. So the first thing I'm going to do, I'm going to go to Y equals, and I'm going to turn my plot on. Again, I went into Y equals, arrowed up to plot, and press enter. If you arrow down, you notice that now that it's highlighted. Okay? All right. So I have to decide what type of regression model this is first. So once I turn my plot on, I'm going to zoom 9. Okay, so if I look at this, this looks like there is a vertical asymptote. And remember what we talked about before, if this is a vertical, if it looks like there's a vertical asymptote, the best fit model is going to be logarithmic. Okay, so that's the first thing that you need to make a determination of. And the only way to do that is to look at the data. All right, the next one says find the equation of the best fit regression model for the data. So now we need to go back to Stat, and this time we're going to calculate. Now you know you're calculating logarithmic. And remember, log, power down, or move down is going to be number 9. It says ln because it's the natural log. So that's number 9. Enter. You do enter, enter, enter. Remember, store regression. We're going to store that into Y1. So alpha trace, enter, and enter one more time. All right, so this is going to give me my best fit model. Okay, so my best fit model, and notice here that it gives me the information about the model, and then all I have to do is substitute in my values here. So I have y equals, A is 6.099, so that's going to be 6.1. Just substituting in, plus B is 6.12, the natural log of x. Okay, so that's my best fit model. Now, let's look at the next question. Using the best fit regression model in part B, predict the height after 15 years. So notice that my data ends here at 11. So I want to know what happens at 15. So at 15, this is an x value here. So I want to know what my y value is. So I'm going to go back to my graph. Notice that I put in a best fit model, which looks very good. And then the next thing I'm going to do is I got to go to calculate, because I want to calculate where x is 15. Well, calculating where x is 15, again, second trace, I'm going to do value, and it gives me, okay, x equals what? Well, x equals 15. It gives me an error message because that value is outside my window. The value is outside the window. You have two choices. You can adjust your window, or you can simply do zoom 3, because I'm going to zoom out so I can see everything in my window. Then go back to second trace, which is calc, value again. And my value is 15. Press enter. So at 15 years, the approximate height will be 22.6 feet. Okay. All right, let's take a look at the next one. The table below shows the number of cell phone subscribers in the Town Hall of Centerville from 2007 to 2015. Let X represent 0, or let X equal 0 represent the year 2000. Then we have our data. Which the following is the best fit for the data? Linear, logarithmic, or exponential? So the first thing I want to point out here is that I have that x equals 0 is 2000, and my chart starts at 2007. So this is going to be 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we're going to enter that information instead of 2007, 2008, 2009. All right, so we're going to do the same thing. We're going to go back to Stat, Edit. To clear your list, if you do clear and then arrow down, that'll clear your list. Clear and then arrow down. Okay, so pause the video, go ahead and input your information into your list 1 and list 2. The year is going to be X, which is list 1, and then the numbers of cell phone subscribers is going to be L2. Okay, so I've entered all my data in. Make sure you always scan through and make sure that it looks correct, because if it's not correct, then you're not going to get the equation correctly. All right, I'm going to go back to y equals. Go ahead and clear out what's there. Make sure your plot is on. So remember, the plot has to be highlighted. And then we're going to do zoom 9 again. Notice this time it looks like I have a horizontal asymptote, and horizontal asymptotes are exponential. So I know that it's exponential. Again, you need to know whether it's horizontal or vertical. That's really your best way to tell whether it's exponential or logarithmic. Okay, so I want my best fit regression model. So I'm going to do Stat, Calc, and this time I'm going to scroll down, and I want exponential regression, which is 0, so press enter. And we're going to press enter down to store, and we're going to alpha trace, because we're going to store it into Y1, calculate. All right, so and again, it gives us here the information about the equation. I just need to substitute in. So I have y equals A is 9.90, and then times B is 1.75. It's off the screen there. 9.90, 1.75 to the power of x. All right, so let's go ahead and look to see how that looks on our graph. We're going to go back to graph. Remember, zoom 9 will make the data points fit into your graph. If you don't see the graph, you may not have turned your plot on. So that fits perfectly. Maybe not perfectly, but close enough. And then the last says, using your best fit regression model, predict the number of cell phone users subscribed in 2017. Okay, so 2017 is an X value. So I want to know what happens in 2017. But remember, 2017 is 17 in our model for our equation that's in our calculator. So 17. So I'm going to do alpha trace, which takes me to calculate value, and put 17. Invalid, which means that I have to zoom out or change your window. right, and let's try that again. So I have Alpha Calc, oops, second trace, value 17. So that is 134400. Number of subscribers. Okay, that's it for this video.